Let's explore Python custom exceptions. In this video, you'll learn how to create and use custom exception classes to handle errors in your Python programs effectively. First, let's cover some Python exception basics. All exceptions inherit from the base exception class. Most custom exceptions inherit from the exception class. Python provides many built-in exceptions, and custom exceptions fill specific needs. Here is an example of basic exception handling. Try block contains code that might raise an exception, in this case a division by 0. Except block catches the 0 division error and prints an error message. The finally block always executes, whether an exception occurred or not, and is typically used for cleanup code. Now let's discuss why you might want to create custom exceptions. Custom exceptions provide specific error types that describe exactly what went wrong. This makes debugging and error handling more precise. You can group related errors into hierarchies, allowing catch blocks to handle entire categories of exceptions with a single statement. It helps to store additional information relevant to your application domain, enabling more meaningful error messages and recovery strategies. While creating libraries or frameworks, custom exceptions provide a clean interface for users to handle specific error conditions in your code. Here's how to create custom exceptions in Python. First, define a custom exception class by inheriting from the built-in exception class. Use the pass statement if no additional functionality is needed. You can also define a custom exception with parameters by adding an init method to the class. This allows you to pass additional information about the exception when it's raised. Remember to call the superinit method to properly initialize the exception. Let's see how to use custom exceptions in practice. To raise a custom exception, use the raise keyword followed by an instance of your custom exception class. In this example, the check value function raises a value too small error if the input value is less than 10, or a value too large error if the value is greater than 100. To catch custom exceptions, use try and except blocks. Specify the custom exception class in the except clause. You can access any additional information passed to the exception through its attributes, such as the minimum value in the value too small error. It's often useful to create exception hierarchies to organize your custom exceptions. Define a base exception class for a specific category of errors, such as database error. Then create more specific exception classes that inherit from the base exception class, like connection error, query error, and duplicate key error. This allows you to catch exceptions at different levels of granularity. Here's how to handle exception hierarchies in your code. You can catch exceptions at different levels of the hierarchy. For example, you can catch a specific exception like duplicate key error, or a more general exception like query error or database error. When catching exceptions, make sure to catch the most specific exceptions first, followed by more general exceptions. This ensures that the correct exception handler is executed. Let's review some best practices for working with custom exceptions. Name exception classes with the word error or exception suffix. Create hierarchies for related exceptions. For large projects, keep exception classes in a dedicated module. Document each exception class with detailed doc strings. Store relevant error information as attributes. Catch specific exceptions before general ones. Re-raise exceptions when appropriate. Use custom exceptions to improve code readability and include descriptive error messages. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.